Okay, today the first thing we're going to do is go ahead and make corrections on your homework. So you can go ahead and press pause and correct this page, and then you can press play when you're ready to move on after making corrections and ready. If you get to anything that you don't understand, I need you to stop and ask me. Okay? And here's the second page. This is never and neither. It's a little darkened here. So go ahead and make corrections on this page. Definitely check your slope. Make sure it's down 5/2 in both directions here. +1 here, up 1/4 on this one. Okay, and when you're done making corrections, you can press play after pausing. All right, let's take a look at the back now. I want to talk about these transformations. For the first one, if we're describing the transformation on the function, this is just a vertical stretch. That multiplying by 3 causes a vertical stretch by a factor of 3. Okay, this one has some shifting going on. This one shifts left 5, up 2, and it is reflected. That negative, the negative out in front, causes a reflection over the x-axis. Okay, now these we're factoring. Hopefully you notice this is a perfect square trinomial, so it factors to square root, sine of the middle. What can you multiply to get -18 that you can add to get 3? That is x plus 6 times x minus 3. Trial and error is the best one for this. We can place a 2 here and a 1 here because that's the only way to get 2. And then I want to multiply to get 15 and add to get -1. So if I put a -3 here, that makes a -6 and a +5. -6 and +5 make the -1. All right, this is another perfect square trinomial. Perfect square. So we take square root, sine of the middle, and if I double the product, I do get the middle term. All right, this one, I'm going to use trial and error again. But I'm going to work off the last term because it's the one that's prime. So I'm going to do a 3 and a 1. So now I need to multiply to get a +10. That gives me +12 and a -2. +12 and -2 gives me the +10. All right. Now this was from our last quiz. Since we're given the information here, we do not have to do anything on our calculator. We just fill it in. It goes forever down and forever up, so the range is from -infinity to +infinity. The end behavior as x approaches -infinity, y approaches -infinity. As x approaches +infinity, y approaches +infinity. The x-intercepts, we're estimating here. We don't have any exact values, but I do see 5 of them. The only one that looks perfect is that 3, 0, so I'll start with that one. Then I would call this one about, 1.75. This one looks to be about 1.3. This one appears to be about -0.2. And this one appears to be about -0.9. And then y-intercept is beautiful right here. It's at 0, -1. Okay, this is a relative max and this is a relative max. We have no absolute because it goes forever up and forever down. So we only have relatives here. So we have a relative max at the points, -0.75, 2.5, and again at 1.5 and 0.42. We have a relative min at the point 0.5, -2.4, and again at 2.43, -4.8. This one is increasing from -infinity to the first x value, which is -0.75. Then it decreases from that -0.75 to the next x value, which is +0.5. Then it increases from here to here, so it's increasing from 1.5 to this x value. It's increasing from the 0.5, to the 1.5. And then it's decreasing from that 1.5 to 2.43. And then it's increasing from the 2.43 to infinity. All right, so we have multiple intervals over which it's increasing and decreasing, so we should connect those with the union symbol. The union symbol is the U. So when you have multiple intervals, you connect them with the union. All right, algebraically, you have to show that if you plug in negative x and you get out the original function, it's even. If you plug in negative x and you get out the opposite of the entire function, it's odd. These are the things we're looking for. All right, so here I plug in a negative. And I'm going to notice the first one changes, the second one doesn't. Neither. On this one, when I plug in the negative, this one changes. This one stays the same. Minus 26. This one stays the same, because when I square that negative, it becomes positive, and this one stays the same. So I plugged in the opposite, and I got out the same. Plugging in the opposite, getting out the original, even. All right, on this one, when I plug in the opposite, this becomes negative, this becomes positive. I plugged in the opposite of x, and I got out the opposite of the whole function. Odd. Okay. Okay, so today we're going to look at two different ways to solve absolute value functions. The first way is going to be graphically, because we know how to graph now. So if we have the equation y equals the absolute value of x plus 3, to graph it, we'd shift left 3, and then we do a positive 1 slope on the right and negative 1 slope on the left, and we'd have this function. So it would look like this. Okay, so what if I took the same absolute value and I said, where does it equal to? Well, this is like the y value. Where is the y value to? So what you would do is you would come over to your graph and you would just take a look. Where are the y values to? Okay, and so it appears we have a y value of 2 here and here. So the solution would be at x equals negative 5 or negative 1. Now let's see if that makes sense when we plug it in. What is the absolute value of negative 5 plus 3? The absolute value of negative 2 is 2. That makes sense. Let's try it with negative 1. Negative 1 plus 3 is positive 2. What is the absolute value of positive 2? 2. So that is one way to solve. Now what if this had said, where is it less than or equal to 2? Same idea. You look at where it hits 2 and where is it below that line. So if I said less than or equal to 2, instead of just being two solutions, this is where it's equal. If I said less than or equal to 2, it's this entire interval from negative 5 to negative 1. Now I'm using the brackets because it has the equal to. So this is one way to use a graph. So let's say we had this function. N of x equals negative 2 times the absolute value of x minus 4 plus 4. So we'd come over to write 4 up 4. My slope is down 2 over 1, opposite going left, down 2 over 1. Okay, and so we're going to graph this function. Uh-oh, I picked the wrong arrow. I picked the wrong arrow twice. There we go. Okay, so I'm going to take this function, I'm going to say, okay, where does it equal negative 2? So if we're looking at equals, where does this equal negative 2? we would come back over here and we would look for y values of -2. It equals -2 in two places. Do you see it here? That is an x value of 1. And here, that is an x value of 7. That's where it equals -2. What if I gave you the same function, plus 4, and I said, where is it greater than, let's go +2. So I'm going to shift this line up so I can see where it intersects +2, and it is greater than +2 from here to here. So that would be from 3 to 5. Now I couldn't use the brackets this time because I didn't have the equal to. What if I had had the same type of problem but said less than 2? So less than 2 would be over here and over here. So that's where I have two different intervals, and I have to join them with the union symbol. So less than 2 from here to here and from there to there. So this part is a lot like our positive and negative intervals, except we're changing. We're not just looking at the x-axis. If this were 0, it'd be exactly like our positive and negative intervals. But we're changing where we draw that horizontal line. All right, now this is the part I like. This is the part we use the most. Algebraically, how do you solve? So go ahead and press pause, write down these steps, and then we're going to do two examples, or a few examples together. All right, so example 1. The absolute value of x plus 2 equals 5. Well, there's two ways this can be true. All of this can equal +5, or all of this can equal -5. And because of that, because the absolute value of +5 and -5 is 5, we really have two equations that we can set up. This equals +5, and this equals -5. Okay, so our steps were isolate the absolute value, which has already happened, set what's inside the absolute value bars equal to the positive and the negative, and then solve. So to solve, we would subtract 2. We would subtract 2. So these two answers are solutions to this equation. If I plug in 3, I get a true statement. If I plug in -7, I get a true statement. Okay, let's try this one. 3 times x plus 1 minus 6 equals 3. All right, so this one we do have to isolate the absolute value. So we're going to move that 6 to the other side. And then we're going to divide by 3. So now we're in the same position. So you set what's in here equal to the positive, what's in here equal to the negative, and solve. So we get x equals 2 or x equals -4. Those are our two solutions. Now we can get some crazy things that happen. What if we isolated our absolute value and we got this? X plus 2 is equal to -3. Is there any way for an absolute value to ever equal a negative number? No. So when you get something like this that doesn't make sense, it's not possible for an absolute value to equal a negative. There is no solution. So that's what I was talking about here in step 3. When we start to solve, you only solve the equations if it makes sense to solve. This is one of those special cases that doesn't make any sense. There's no way an absolute value can equal a negative number. Okay, the last thing we want to talk about is how does that change if it's an inequality? The absolute value of x minus 2 greater than 4. It's the same idea. All of this greater than 4. Or this is where when we change to the negative, when we change to a negative, it's going to flip this sign, less than -4. So when we have inequalities, the first one's the same, the second one switches the sign of the number and changes the inequality. And then you just solve. Now remember, when we solve inequalities, if we have to multiply or divide by a negative in order to solve, then we would switch the direction of our inequality. Okay, so let's do one where we have extra stuff that we have to get rid of first. Let's say we have -3 greater than x plus 4 minus 1 is greater than or equal to -7. So first of all, we have to isolate the absolute value. So we'll add the 1. And then divide by a negative. Okay, I'm dealing with an inequality and I'm dividing by a negative. So the first thing you have to do is change the direction of the sign. All right, so less than or equal to 2. So we set up our 2 equations. Switch the inequality, change the sign. So we solve this one. So one solution is x is less than or equal to -2. Our other solution is x is greater than or equal to -6. Now, we could actually write this as a compound inequality because these two do go together. All the values of x are between -2 and -6 and -2. And tomorrow we'll talk about how we could show that on a number line or as interval notation. Now the special case here, what if we got this? X plus 4, let's change. Here's a special case. 2x minus 1 is less than or equal to -3. Once again, is there any way an absolute value can be less than a negative number? Absolute value is always positive. So when you isolate your absolute value, if you have a statement like this, there's no need to solve. There is no solution here. Now, there's one more special one with inequalities. What if we have the same thing, but we have where it's greater than a negative number? Well, all absolute values are greater than a negative number. So no matter what value I put in for x, this is true. Ignore that bell. It is all real solutions. And that's it. Start your homework.